Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangad PG College, Didwana. We started a lecture series on database and management system. In this lecture series, in just previous lecture, we discussed about the drop table concept and alter table concept under data definition language. In DDL, data definition language, it mainly deals with table structure, about integrity constraint, deciding the primary key and foreign key, and just altering or dropping the table attribute. Means just physical storage of the relation. All these things comes under data definition language category. Okay. After that, we started SQL. In SQL, we can make queries with help of various clauses or various statement like select, from, and where. And basic structure we have discussed. In today's lecture, we will start from basic structure of the SQL, and after that some detailed concept we will be discussing. In this lecture series, data definition language already discussed in the previous lecture. Basic query structure and some set operation we will be discussing in today's lecture, right? So basic query structure. In SQL, it is basically based on set and relational operations with certain modification and enhancement. A typical SQL query has the form select clause. In this, write down all the attribute which are we want to pick in the final output. So A1, A2, AN, this will be picked and put in the final output. From which relation we want to fetch the relation information. So R1, R2, all the required relation, where P means predicate condition. So here A of I represent an attribute, R of I represent a relation, P is a predicate. Okay. Now, if we are writing this query in relational algebra, then in relational algebra for select we are using pi. Corresponding to select we are using what? Pi. In pi we are writing all the required attribute. Okay, list of the attribute. Here we are writing in select all the attribute, and at place of select we are writing in relational algebra pi, and attribute list are written as the suffix. At place of from we need to write down in bracket the name of the relation, right? And at place of where we are writing what? Sigma operation. Sigma is standing for select operation, and in sigma we are writing a predicate. At the suffix we are writing predicate condition. So select operation in SQL equivalent to pi operation in relational algebra. From clause in SQL is equivalent to in bracket R relation name in the relational algebra, and where clause with predicate P is equivalent to sigma operation with P in relational algebra. Okay. Now very important point, the result of an SQL query is a relation. Okay. Now we are going in detail about these clauses. First clause is select clause. The select clause lists the attributes reside in the result of a query. Clear? It corresponds to the projection operation of the relational algebra. Right? Now example, if we want to find the names of all the branches in the loan relation, then how to write down? So first thing we want to pick the information from where? Branch relation. All the related to all the branches means we want what? Name of all branch. So branch name attribute we want to pick, and from which relation? Loan relation. In from we need to write down loan. So step by step, select clause to pick the required attribute. So which attribute we want? We want branch all the branches. It means names of all branches. It means branch name will be the attribute which we want to pick. So select branch name. Next is from which relation? Loan relation. Okay. If we want to write down this same query in relational algebra, which we already covered, then how to write down? Pi operation. We need to write down pi, and what we want to pick? Branch name. So here we want to write down branch name, and from which relation? Loan relation. It is written here pi relation, then branch name, and from which relation? Loan relation. So in this manner we can write down the queries here. Now one question is coming in your mind that why we haven't written here where clause. So the point is that where clause is used if and only if we require some condition. There is no condition in this query. Find the name of all the branches in the known relation. Straightforward, it is asking about the information, not putting any restriction or any condition. Clear? Now one note point is written here. SQL names are case insensitive. Insensitive means it is not, that is you may use upper or lower case letter. They are same. Case insensitive. Very important point. Insensitive, right? So upper or lower case letter are similar. Example, if we are writing branch name equal to branch name all capital letter, toggle case letter either all capital or all small, all are taken as same. Some people use uppercase whereas we use bold font, right? Now SQL allows duplicates in relations as well as in query result. There may be duplicate tuples or duplicate values corresponding to two rows in a same attribute. Okay, to force the elimination of duplicate, insert the keyword distinct after select, right? So distinct keyword is very important. If you put this, then it will remove the duplicacy or redundancy automatically. Suppose one query is, and some queries are listed here. Find the names of all the branches in loan relation. So relation name is loan, and what we want? Branch name. The branch name is required attribute, come in select clause, and loan is coming in the from clause. And remove the duplicate. If you want to remove the duplicate, how to remove the duplicate? It means while picking the attribute, picking means in select clause, while writing the required attribute, before that we need to write down distinct command. So how to write down? Select, to select the required attributes, distinct command to remove the duplicacy, and what is the required branch, column name? Branch name. Okay, so select distinct branch name. From which relation? From loan. Next, the keyword all specify the duplicates not to be removed. If we want to pursue with duplicates, rows and duplicate tuples also, then at place of distinct we need to write down all, right? So if we are writing select all branch name from loan, so it will give all the duplicates value corresponding to branch name. An asterisk is the select clause which denote all the attribute. Suppose in a table there are three attribute, and in the output we want to pick all the three attribute. Okay, all the domain value corresponding to these three attribute. Then rather than writing all three attribute, we can simply write down asterisk symbol under select clause. So how to write down? Select, after that we need to write down all the attributes, but rather than writing all the attributes I am writing only star. From which relation? Loan relation. Now here the select clause can contain arithmetic expression involving the operation, all the arithmetic operation like plus, minus, multiplication and division, and operating on constant or attribute of the tuples. Some examples are written here. The query is written here. Select loan number, branch name, amount into 100 from loan. So it will return a relation that is same as loan relation, except because in loan relation there are loan number, branch name and amount. But here we are multiplied amount attribute with 100. So what will happen? It would return a relation that is the same as the loan relation, except that the value of the attribute amount is multiplied by the 100. Next is where clause. The where clause specify conditions that the result must satisfy. It is corresponding to the selection predicate of the relational algebra. Okay, if we want to put selection or sigma operation, then where clause is required here. Suppose some query to find all the loan number for loans made at the parish branch with loan amount greater than $1,200. How to write down? So we need to write down select loan number from where? Loan, where the branch name is parish. Okay, there are condition. First we want all the loan number. So in the select close loan number we need to write down select close loan number for loans made at parish branch. So condition is that the branch name should be parish with loan amount greater than two conditions are there. Branch name should be parish, at the same time the loan amount should be greater than 1200. So see, both are picked from where? Loan relation, where condition branch name should be parish and at the same time amount should be greater than 1200. So comparison results can be combined using the logical connective and or and not. So these logical connectivity we can write down in order to satisfy more than one condition either simultaneously or either or condition or and condition or not condition, right? Next is comparison can be applied to the results of arithmetic expression like SQL include between comparison operator. One query is there. Suppose find the loan number of those loans with loan amount between $90,000 and $1 lakh dollar. That is between 90,000 and $1 lakh dollar. So how to write down? Here we require what? Loan number. So loan number will be put under select close and the attribute name is loan number. For those loan with loan amount between 90,000 to 1 lakh. So here a condition is on amount. From which relation we want? From the loan relation, because loan number attribute is present in loan relation. Where condition is on amount attribute, and what is the condition? Between. It should be between 90,000 to 1 lakh. So how to write down? Between and operator is available in SQL, where column name is amount on an amount attribute condition is put. So where amount, between is the command, between is the operator, 90,000 and 1 lakh. Between and means the lower limit is 90,000 and upper limit is 1 lakh. Okay. So in this manner we can do. Okay, the from clause list the relations. The from clause list the relations involved in the query corresponding to the Cartesian product operation of the relational algebra. Suppose we want to find Cartesian product borrower and loan. So how to write down? Select, then we need to write down the operation or operator name is cross from borrower and loan. In this manner we can write down. Now see, find the name, loan number and loan amount of all customer having a loan at parish branch. So here we require name, customer name, loan number and loan amount. If you see name is present in customer table, right? Loan number and loan amount is present in the loan table, and branch, parish branch means it is related to branch. Okay, so we know that branch name, customer name is present. If they are taking loan, it means it is related to borrower table, right? Borrower table and loan table. So select customer name, borrower dot loan number will be taken from borrower relation, because those customer who are having the loan, so loan number will be picked from borrower relation, and amount from borrower and loan relation, because we require information from two relation, where borrower dot loan number should be equal to loan dot loan number. This line is written in order to remove the duplicacy, because in borrower and loan table loan number attribute will be same. In loan table loan number attribute is primary key, and in borrower table loan number attribute is foreign key. And one more condition is there, branch name should be parish, right? Next is rename operation. The SQL allows renaming relations and attribute using the attribute as. How to write down? Old name as new name. In between we need to write down first old name, then new name, and in between as. Suppose example, find the name, loan number and loan amount of all customer. Rename the column name loan number as loan underscore ID. How to write down? So in the select we require customer name, borrower dot loan number as. From the borrower table we want loan number, but we want to rename it as loan underscore ID. So as operator is there, and before as old name, and after as we require the new name. Okay, and then amount. From which relation? Some information from borrower and some from loan. And where close we are writing to remove the duplicacy, because by default in borrower and loan one attribute is common, that is loan number. So borrower dot loan number should be equal to loan dot loan number. So in this manner we can perform SQL query, and rename operation can also be implemented. That's all from this lecture. Thank you.